So hey guys, this is Dipesh, and in this particular video we'll look more in depth about the workflow of the overall machine learning project. More specifically, I will tell you how we can basically convert categorical features or categorical variables into their numerical format. Alright, so yeah, let's get started. So in our previous lecture, I told you that there are basically three types of variables. Alright, now again, variables are basically this, each column represents one variable. Alright, and variables are also called as independent variables or features or dimensions. Alright, so basically all these terms or terminologies just mean the same thing. All right, so again, the we have mainly three types of variables: discrete variables, continuous variables, and categorical variables. Now discrete variables and category and continuous variables are already in the numerical format, right? But categorical variables are not in their numerical format. So for example, here you can see that the job role, okay, the job column consists of three classes: software engineer, data scientist, machine learning engineer, right? Now how can we convert these strings into the numerical format? Because we know that machines can only understand numbers, right? So how do we convert this numeric string format, this textual data, in numerical format? Okay, so that is what we will basically discuss in this video. Okay, so now in our previous lecture, I already told you what a categorical variable is. Okay, now there are basically two types of categorical variables. First is ordinal categorical variable, and the second is nominal categorical variable. Now, we know that categorical variable basically means classes. All right. So, for example, the gender column, you can see here that it consists of classes. It consists of two classes here. One is male class, and the second is female class. Right. So this is basically categorical variable. Now, what is ordinal categorical variable and what is nominal categorical variable? So there is only one major difference between these two types of categorical variables, that is the natural order. In ordinal categorical variable, in ordinal categorical variable, there is a natural order among the classes or among the values. All right. So for example, you can see the customer rating column here. Basically this entire table represents the data for some hotel waiter. Okay, for hotel waiters and waitresses. All right. So the data includes their name, their gender, and their customer ratings. All right. So basically, this column represents two columns which consist of categorical variables. There is the gender column, and then there is customer rating column. Okay, both are categorical variables, but the gender variable is a different kind of categorical variable, and the customer rating column is a different type of categorical variable. All right. So now, what is the major difference between ordinal categorical variable and nominal categorical variable? Now, in ordinal categorical variable, there is a natural order to the classes. So the customer rating, okay, the customer rating column is basically an ordinal categorical variable, because there is natural order to the classes. So it consists of basically it consists of four different classes: good, bad, very good, and excellent. Now we know that there is a increasing pattern here. We know that we know that good is better than bad. And excellent is bigger than very good. So there is basically a natural order coming here. So this is what you call as ordinal categorical variable. And then there is nominal categorical variable. Okay, nominal variable is kind of like an opposite of ordinal categorical variable. It doesn't consist of any natural order. For example, gender. Like in gender we have two classes, male and female, but we cannot say that one class is bigger than another. All right. So this is basically the major difference between ordinal and nominal categorical variable. So before we begin, uh, it is very important that you understand that there are different types of methods that we can use to convert categorical variables into the numerical format. Okay. Now, depending upon the type of categorical variable you are dealing with, you will use different type of methods. But mainly there are two types of methods to convert categorical features into numerical format. One is the one-hot encoding, and the other one is label encoding. Okay. Usually the general rule of thumb is that we use one-hot encoding for nominal features, and then we use label encoding for ordinal features. Okay. There is no predefined rule or something like that, that you have to use only one-hot encoding for nominal features and only label encoding for ordinal features, something like that. There is no such rule. But this is basically common practice that we follow, that we use one-hot encoding for nominal features and label encoding for ordinal features. All right. Depending upon your use case, you can use both these methods, and you can see how your model performs, and you can choose the model which gives you the best accuracy. All right. Okay. Now let me show you how each of this method works. Okay, first I will show you how one hot encoding works, and then I will tell you how label encoding works. Also, keep this in mind that don't worry about implementation at all. Okay, don't keep thinking about how we will implement this using coding, or how we will implement this in any programming language. It's very simple. In with Python we get a large number of tools for implementing such things. So this kind of things, we can do these things in like 2 or 3 lines of Python code. So don't worry about don't think about how we will code these things at all. Just take a high level overview of what I'm explaining here. In the next part of this video, I will try to implement both these methods on a test data set. Okay. So yeah, so first let me explain you how one hot encoding works. All right, let me clear this. All right, so what we'll do is we'll use one hot encoding to convert the gender column into its numerical format. So in one hot encoding, what we do is we basically create multiple columns for we basically create a new column for each class. Okay, and we put ones and zeros in those columns. Okay, so for example, if I wanted to convert gender, this gender column into its numerical format, what I would do is I would basically first count how many classes I have. So the gender column basically consists of two classes, right? Let me write this here: gender column, gender variable, two classes. Okay, so now we know that the gender column basically consists of two classes. So what we'll do is, when we are using one hot encoding, we'll create two extra columns. Since we have two classes in gender, we'll create two extra columns. Now each column will represent one class. So basically this new column will represent male class, and this new column will represent female class, right? So what we'll do is we'll create those new columns. So let me name this as male, and let me name this as female. Okay. All right. Now again, like what we are doing is we want to convert this gender column into its numerical format. Okay, basically we want to convert this categorical feature into a numerical format using one-hot encoding. So what we did was we first found out how many classes does this variable consist. Now since it's a gender variable, it consists of two classes. That is, one is male and female. So what we did was we created two columns, two extra new columns, for one column for each class. Okay, and we name them according to the classes. Now what we do is we put ones and zeros wherever the value of that particular class is present. So for example, the first row, the gender is male. Okay, so what I will do is I will put 1 in the male column, and I will put 0 in the female class. Okay, I'll do the same thing for the second row. For the second row, the gender is female, so I will put 0 here, and then I will put 1 for female. Okay, I will do the same thing for the third row, the gender is female, so I will put 0 for male, and I will put 1 for female. So basically this 1 basically means true and 0 basically means false. Alright, so this is how basically one-hot encoding works. Okay, we count the number of classes, alright, and then we create those extra new columns for each class. So now let me complete the for the rest of the rows. So here the gender is male, so we'll put as 1, which represents true, and I will again put as 0 in the female, and let's do this for the final row. We'll do 1, and we'll do again 0. Alright, now basically what we can do is we can, even if we remove the gender column, we still don't lose any data. Okay, let me do this. Even if we cancel out this, okay, even if we cancel this out, we don't lose any data here, because we have now successfully converted this column, this categorical feature into a numerical format. All right, now in a real world scenario, we would stop here after converting all the variables into a categorical features. All right, but we still have one variable remaining. All right, now what we'll do is we'll use another method called as label encoder. Okay, label encoding, to convert the customer rating column into its numerical format. Okay, also I will tell you why we should not use one-hot encoding when there is high cardinality in the categorical variable. So let me explain this to you. Now imagine, now the gender class basically consists of only two classes, right? Male and female. So we only had to create two extra column. But imagine the customer rating column. The customer rating column consists of 4 classes here, 4 unique classes. So we would have to, if we use one-hot encoding, we would have to create 4 extra columns here. We would have to create 4 extra columns here. Now imagine what would happen if we had 10 classes or 100 classes here. In the real world cases, it is very much possible. If the categorical features consist of a large number of classes, that is, its cardinality is very high, then it is not feasible to use, it is not efficient to use one-hot encoding, because what we'll do is we'll keep on adding extra columns to it, and as you can see, there most of the columns will consist of only zeros. Okay, because only one class would be present here. For example, here the customer rating column, it has 4 columns. So if we created 4 extra columns, if we create 4 extra columns where each column represents one class, good, very good, and bad, then at each row only one column will consist of any real data. For example, if first row is good, then the column representing this good class with will only consist of will be the only column that consists of 1, and rest all columns will consist of zeros, you know. So if we have like 100 columns, 100 classes in our categorical variable, and we created 100 extra columns, then 99 columns will consist of zeros only, like they won't give us any extra information. All right. So if you have very high cardinality in your categorical variable, you know, then you should not use one hot encoding. Okay. So a general rule of thumb is, if you have more than 5 classes for any categorical variable, then don't use one hot encoding. All right. In that case, you can try using label encoding. Okay. You can try using label encoding. Now we let me show you how we can basically use label encoding to convert this customer rating variable or feature into its numerical format. First, let me clear this up. Okay. All right. So label encoding is very easy. So basically, in one hot encoding, what we did was we created extra columns, right? But in label encoding, we don't create extra columns. Rather, what we do is we create just what we do. So basically, in one hot encoding, we create the extra columns for basically we create in new column for each class, right? So in gender variable, we had 2 classes, right, male and female. So we created 2 extra columns. But and if we use one hot encoding to convert customer rating variable, then it has basically 4 unique classes. So we would have to create 4 unique columns here. Okay. But in label encoding, we don't create extra column, we just create one column. Okay. We just create one new column. Okay. Let me show you how this works. So what we want to do is, we want to create this customer rating column into its numerical format using label encoding. So how do we go about this? So the first thing that you do in label encoding is, you basically assign a label to each class. Okay. So what you do is, you assign a label to each class. So for example, you basically assign a numerical label to each class. So for good, I can say 1 represents good, and for very good, I can say 2 represents very good, and then again I can say that 3 represents bad, and let's say excellent is represented by 4. Okay. So in this way, what we do is, we basically assign label to each class first. All right. And then what we do is, all we have to do is just replace these classes, these values, with these new numerical labels. Okay. So let me write this here again. So the label for good is 1, the label for very good is 2, the label for bad is 3, and the label for excellent is 4. All right. So basically, we assigned a numerical label to each class here. Okay. Now here it doesn't matter how many classes you have to assign the numerical label to each class. So now next, what you have to do is, what you can do is you can change these variables. Okay, you can change the actual variables here in the customer rating column. You can basically change the change or replace the values with the labels. Okay, so let me basically create a new column to show you an example, to give you an example. Okay, all right. So we have assigned a numerical label to each class, and now what we do is we create a new column named as new rating. Okay, and what we do is we assign we basically replace the actual value with the numerical value. So for good, we know the label is 1, so we put 1 here. Then again the label for very good is 2, and the label for bad is again 3. Okay, the label for excellent is 4. All right, again the value is good, so now we know that the value label for good is 1, so we just put 1 again here. All right, now what we did was we basically just assigned unique labels to each class. Now what we can do is we can, even if we remove this column, we don't lose any information. Okay, we don't lose any information because we already know the labels, we already have the labels. We can just by looking at this new table, we can say that okay, 2 represents very good, and 1 represents good, something like that. All right, so this is how we basically convert categorical variables into their numerical formats using label encoding. All right, so this was it. In the next part, what I will do is I will try to I will take a test dataset and I will convert the categorical variable into its numerical format using both one-hot encoding as well as label encoding. Okay, so yeah, that was it for this video, and see you.